So these molecules, organic molecules, which could be the building blocks of life, they're formed on the surface of the comet by the interaction of the solar UV light with the water and carbon dioxide on the comet.
So essentially the UV light strikes these molecules, fragments them, and then they recombine. They can recombine into completely random, massive structures, which is what's been found with these organics. In the question, it was also asked if these are fragments from the explosions of stars. It's a point in astronomy that anything heavier than hydrogen is called a metal, and these atoms themselves were formed in supernovae very early in the age of the universe. And it's these primordial atoms which form together to form the water and CO2 in the first place, which these processes then convert to organics. There's a lot on the cards. There's of course the European Space Agency ExoMars mission heading off to Mars in 2018. There's some precursor missions going in 2016. There are many small private missions going to the moon as well as part of the Google Lunar X Prize. So take your pick really. It's an ever-expanding market.
How long will we be able to keep in touch with the spacecraft and with Philae? Philae, if it carries on operating in communications, could continue until the comet starts moving too far from the sun, which will be about December this year or maybe January next year. The spacecraft, I think they've had the mission extended till September time next year. So that's another year to go before it starts getting too far from the sun, and then the solar power is not enough to keep the spacecraft operating, and the fuel is not enough fuel to keep the spacecraft in orbit around the comet. So that's the point. They've got to decide what to do with the spacecraft. Do they actually drift away from the comet and get long-range observations, or more exciting would be to actually try and land it on the comet, get in close and maybe go for a fifth landing on the comet. From our point of view with our instrument, we can't detect molecules directly that are products of living processes. So our instrument can't determine that. There's another instrument, COSAC, which can look at amino acids, and we're still waiting to find out if they actually detected amino acids, but we think if there are amino acids there, they'd have been formed by processes on the comet, so similar to the molecules we detected. There's been no evidence of any life being detected on the comet, and certainly nothing waving at the cameras. So that's the best way of seeing life.
I think it's more the idea that life forms on, say, Mars and comes in meteorites.
And personally, I think panspermia doesn't really answer the question, because all it does is put the question back, how does life form in space or on other planets? So really, it doesn't help in finding where life comes from. Whereas from what we found on the comets, we can do the first step of getting the building blocks. The next step is beyond our expertise, and it's for other scientists to look at building on these results. One of the lab experiments, is we did this before we actually got to a comet, is building what we think a comet looks like from raw ingredients. And we start off with dry ice, which is very white, and we add a bit of soil, which is some of the organic matter, and ammonia, window cleaner, it's got ammonia in it, so that we add some of that, and we mix it all together. And we add some more organics, which is the Leo-pairing source. Maybe that's the type of organics that are on these comets. And you get a lump about this sort of size, and it's hissing and popping, and you get little jets of steam coming out of it. And one of the very interesting things, it becomes very, very black. So even though most of it is white dry ice, you get a very black, dark surface. So it's similar to what the comet actually looks like. And we build these in the lab, and I believe there's a lab cast which shows this being built at the Open University. And the Leo-pairing source, as I say, is the organics. For some strange reason, you get a much better comet if you use Leo-pairing source than anything else. So that's why it's there on the table there. Yeah. It's our source of raw ingredients.